Yeah, so welcome, my viewers, to Mwalimu Ignatius Wahome YouTube channel. And today we are going to cover Form 2 mathematics. So, under Form 2 mathematics, on part of volume of solids, that is the volume of a frustum of a cone. Volume of a frustum of a cone. So, welcome. So, the question is here on the board, and it reads like this. So, a bucket that is in the shape of a frustum of a cone has a top radius of 12 centimeters and a bottom radius of 8 centimeters. So if it's 20 centimeters deep, find its capacity in liters. Find its capacity in liters. So step number one for this one is to make a sketch of the shape of this bucket. It is the shape of a frustum of a cone. So the top radius is 12 centimeters. That's all. Top radius there. R is 12 centimeters. That's top radius, 12 centimeters. And the bottom radius here is R is 8 centimeters. And then the height of this bucket is 20 centimeters. That's the step number one. You make a sketch of the bucket. So make a sketch of this bucket. Then the next thing, because our frustum is a cone, is a cone where the one part of the cone has been cut. So therefore, you extend up to this point, the top part of the cone has been cut for you to get the frustum. So this now the bucket that is in the shape of a frustum. So it looks like this. So you are supposed to extend this one, show with these dotted lines there, where this cone should be. So in this case, the examiner is testing the volume of a cone. The volume of the frustum is calculated by finding the volume of the original cone minus the volume of the cone that has been cut. You get the volume of a frustum. So that is, you need to know how to deal with the volume of a cone. So therefore, once you do that, then you take this, the height of the small cone that has been cut as h. The height of the small cone that has been cut as h. So therefore, find the height of the original. The height of the original cone before a small cone was cut. This is h plus 20. H plus 20, because the height of the cone that has been cut is already, it's h. And then the height of the frustum is 20. So the height of the original cone is h plus 20. Then from there, once you do that, the next step, you are supposed to use similarity now. Now similarity in Form 2, where you are supposed to compare the radius of the small cone and the radius of the big cone, or over the height of the small cone and the height of the big cone. So therefore, for you to get the height of the cone that has been cut, so take this r over r, that's the radius of the small cone, over the big cone, and the height of the small cone, which is equal to h, all over h plus 20. So it should always be like that. So you are using similarity to compare. Using similarity. So r all over r, the radius of the small one over the radius of the big one. Then the height of the small one all over the height of the big one. So that is the original cone before it was small cone was cut to get the frustum. So get h plus 20. So that's what you do. So now from there, so our r is 8, and r, the radius of the big cone, is 12. So you get h all over h plus 20. So you need to find the height of the cone that has been cut. So that is step number one. So at this level, you can simplify this. You can simplify 8 divided by 4, you get 2. And this 12 divided by 4 is 3. You get 2 over 3 equals to h plus 20. So that's what you get. That's what you get. That's what you get. Then from there, what you do, you cross multiply. The easiest way to get the h is you cross multiply. You get this h plus 2, you bring it here, h plus 20, bring it there, and then this 3 becomes 3h now, when you cross multiply. And then you open the bracket. You open this bracket. So this one you say 2h plus 40 is equal to 3h. That's what you do. So you want to get the height of this cone that has been cut. So therefore, so take this 2h to the right, and you say 40 is equal to 3h minus 2h. Also on the right hand side, you are supposed to subtract. So therefore you get 40 is equal to h. So the height of the cone that has been cut is 40 centimeters. The height of the cone that has been cut is 40 centimeters. The height of the cone that has been cut is 40 centimeters. So therefore, the height of the original cone will be now h is equal to 20 h 40 plus 20. You get the height now is 60 centimeters. You get the height of that cone is 60 centimeters. So the height of the cone, the original cone, in this case, it is 60 centimeters. So that's what you do. That's what you do. That's what you do to work out that. So once you get the height of the small cone, that is 40 plus 20, now you get the height of the original. Then the next step now, it's to find the volume of a cone. The formula of finding the volume of a cone. The volume of a cone. The volume of a cone. So that's the next step. So the volume of a cone, volume of a cone, a cone. In this case, it's got by that pi r squared h. That pi r squared h. So therefore, when you need this volume of this bucket, you'll find the volume of this big cone, which is abad times pi. We can take pi as 22/7 times r squared. R is the radius of the big cone, original cone, times now the height of the original cone, which is 60, minus that times now the radius pi 22/7 times r squared. The radius, the small one, h squared, and the height, the small height, is 40 times 40. So that is the height of the cone that has been cut. That's the height of the cone that has been cut. So therefore, so take that times 22/7 times 12 squared times 60. And in this case, you get, this is 51.43 centimeters cubed. 51.43 centimeters cubed. Then you find the volume of the small cone, that times 22/7 times 8 squared times 40. In this case, you get 2681.90 centimeters cubed. 2681.90 centimeters cubed. So that's what you're supposed to do. That's what you're supposed to do. Get that. Then from there, you find now the volume of the frustum. It's the volume of the original cone minus the cone that has been cut. So volume of the frustum now, volume frustum. The volume of this frustum will be 9051.43 minus 2681.90. That's what you do. Subtract that. 9051.43 minus 2681.90. This comes to that is 6369.53 centimeters cubed. That is 6,369.53 centimeters cubed. Centimeters cubed. But remember, you are told find its capacity in liters. Capacity is volume in liters. So therefore, you're supposed to convert this one to liters. So what do? You say 1 liter is equal to 1,000 centimeters cubed. So this answer that you have got here of 6369.53 divided by 1,000. If you divide by 1,000, you get 6.36953 liters. 6.36953 liters. Give your answer is this. Or maybe to for significant figures, it can be 6.3 953 becomes 6.370. We give you answer to four significant figures. So it should be like that. So this is the capacity of this bucket in liters. And that one is how you find the volume of a frustum of a cone. The volume of the frustum of a cone. So thank you very much. So that was Mwalimu Ignatius Wahome YouTube channel. Thank you for listening to this question. So remember to subscribe at the end of the lesson. So welcome. So Mwalimu Ignatius Wahome YouTube channel.